Hi, I'm Dr. Umair Munir. I'm PhD in Mechanical Engineering. In this video, I'm going to present a 3D transient CFD engine simulation which is capable of predicting the PV power of the engine, and it can predict the heat transfer characteristics of its heat exchangers. The model that has been developed is for a free piston Stirling engine, and this model can be applied to any other engine with moving pistons and heat transfer. This figure is showing the pressure variation inside the engine. There are two pistons moving that are shown in the figure. One is the displacer piston, the other one is the power piston, and due to the movement of the pistons, pressure is changing inside the engine, and by drawing the pressure volume diagram we can find out the indicated power of the engine. This figure is showing the heat transfer inside the engine and temperature variation. It has a channel heater and a tubular cooler. The heat is transferred from the heated walls to the working gas, and we can find out the heat transfer characteristics for each heat exchanger configuration. So this CFD model is capable of analyzing the heat transfer as well as fluid flow characteristics of the heat exchanger channel. A 2D CFD model with moving engine walls and heater and cooler heat exchangers is also developed, which is the simplified version of the 3D model. It has less computational cost and predicted the similar results of indicated power and heat transfer characteristics of the engine. This figure shows the pressure variation in the 2D axisymmetric model of the engine. The motion of the walls has been controlled by defining a user-defined function which defines the motion of each wall of the piston. Now this figure shows the variation of temperature in different spaces of the engine during the complete working cycle. The model consists of a heater, cooler, and a regenerator. The regenerator works as a heat reservoir and a thermal barrier between the two heat exchangers. This model is also capable of predicting the heat transfer properties and flow characteristics. Finally, this figure shows the streamlines and flow vortices inside the different engine spaces. If you need any help regarding this topic and how to develop the dynamic simulation or transient simulation of an engine of any type, you may contact me for help. Thank you for watching this video.